Hello everyone, and welcome to the Milestone Project 1 Complete Solution Walkthrough. In this lecture, what we're going to be doing is going through the entire walkthrough solution, each of those steps, solving those functions. So we're going to be going through each major function, try to solve and create the function on your own first, but let's go ahead and jump and get started to the Jupyter Notebook and see what's going on. Okay, so here we are at the Milestone Project 1 Walkthrough Steps Workbook. What I've done is I've downloaded this Jupyter Notebook to my local computer so we can actually go through each of these steps, fill out the functions, and make sure we match up correctly with the solutions notebook. So if you want to follow along with the actual code I'm going to be doing, you can go to the other notebook, which is Milestone Project 1 Full Walkthrough Code Solution. And this is basically what we're going to be doing. I'm going to be typing this out and explaining the logic along the way. Let's go ahead and get started. So again, if you want to follow along here, what you should be doing is you should have downloaded this notebook, Milestone Project 1 Walkthrough Steps Workbook, and be following me working through it. And before we do each step, I'm going to really stress that you should pause the video and really try to solve this on your own. It's going to be really helpful if you give it a fair shot at solving it on your own. Okay, with that being said, first thing we're going to say is from __future, import the print function. I'm just doing that so I can always use the print function. So for example, I can do something like this. Hello. Instead of using the print statement, which would have looked like that. That's just to make sure whether people are using Python 2 or Python 3, all the code matches up. So if you're using Python 2 like I am right now, go ahead and put this line here. If you're just using Python 3, you don't have to worry about this line. You can just use the print function naturally. One other note that I want to make sure you guys realize is Python 2 users, you'll notice throughout some of the functions we're going to be asking for input from the player. Python 2 users should use raw input to get the player input. Python 3 users should just use input. We'll go over that later on when we actually use those functions. Alright, so what's our first step? First step is to write a function that can print out a board. We're going to set up our board as a list where each index, 1 through 9, corresponds to a number on a number pad. So you get a 3x3 board representation. Here, what I've done is I said from ipython.display import clear output. That just allows us to clear the output. So I'll show you an example of that. If I say print hello, I get hello here. Let me go ahead and run this. So I've imported clear output. So I just ran the cell, but now I'm going to say clear output. No, just no other arguments, close the parentheses. And you'll notice it will basically print hello and then clear the output so you don't get anything out. And if I add another print statement after that, like world, then I just get world out because it printed hello, it cleared the output, and then printed world. It happens so fast that you only end up seeing world at the end. But I just wanted to clarify that's what clear output is doing. That's for Jupyter Notebook. You may need to use another output or a clearing of output if you're using a different IDE or development environment. This is what you have to do for Jupyter Notebook. Say from ipython.display import clear_output. Okay. You can go ahead and Google search for your particular developer environment what you should do to clear the output. So first thing we're going to do is write a function that can print out the board and set up our board as a list, where each index, as I mentioned, corresponds to a number on the number pad. First thing I'm going to do is say clear_output. That way, every time I call display board, all the previous output is cleared, and then I can actually print out a board. Alright, so here again I'm going to stress that you pause the video and really try to think, how can you display this board? Alright. Now let's go ahead and continue. Hopefully you've had a good shot at this now. But when I say print board, all you have to do is, let's go ahead and practice printing an empty board. So an empty board might look something like this. If I say just a string that looks something like this, then right below it I'll print maybe another string that looks something like this. Maybe it has A couple more dashes there. But this is basically all this step was trying to make you do. Just print out a board right now. And then later on, in just a second, we're going to add what we would need to add to take in a board and print it out. But let's go ahead and just practice this. If I call display board, let's see, and pass in a board, in this case, I'm just going to pass in an empty list. You notice we get a very simple board, and we're actually missing a couple lines here, but we'll get to that in a second. What we're going to do now is go ahead and assume that our board is a list that looks something like this. The board is going to be a list from 0 to 10, and it's going to have corresponding strings. So we'll ignore the 0 index, so don't worry about that. But it's going to look something like this, where each of these indexes matches up with some sort of position. So if I do something like this, blah, 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 all the way on, what we're going to do is have a board that looks something like that. So I'm going to go ahead and there's a lot of print statements here. So I'm going to copy them from the solution notebook, which you can do as well. And then I'm just going to go ahead and call this and explain what it looks like. I'm going to go ahead and make a board. I'm going to say it's X, so we're just going to have all X's, and let's multiply this by 10 and say display board, call in the board. Let's go ahead and see what that looks like. Alright, so now we have a board full of X's. And I can edit this list so that I have zeros in there too, or O's I should say. So I can do something like X, X, then let's have copy paste this. Let's do O's. And if you notice, I get my list index out of range because I need to have one more there. The reason for that is because we're using 1 through 9 so that the numbers correspond with a number pad. So if you notice up here, I'm indexing 9. And that's because we're always just going to ignore the 0 index. So this can actually be pretty much anything you want it to be. It's just always going to get ignored for this particular displaying of the board. That way, if you notice here, 1, 2, 3, 4, 5, 6, 7, 8, 9, it looks and matches up with the numbers of a number pad. So that's the function display board. Let's go ahead and break it down one more time, just zoom in what's really going on here. We're printing a line, that's the top of the tic-tac-toe board. Here is where we're actually taking the string values from that list and then adding empty strings plus those vertical dash marks in order to construct the board. Okay, so that's our display board function. Again, we're just taking in a board. We're assuming that it already has 1 to 9 correspondence with some sort of number pad. And then we're just printing out the values so that we get something that looks like this. You can choose however you want to display the board itself as far as dashes or lines, but this is the basic premise of what this function and step was trying to get you to do. Okay, so we've done that. Let's go ahead and go on to the next one. Next one is write a function that can take in a player input and assign their marker as X or O. And what we want to do is think about using while loops to continually ask until you get a correct answer. Alright, I encourage you, again, to pause the video now and see if you can solve this on your own. Alright, let's go ahead and get started. I'm going to say marker equal to just an empty string. That way I actually define my variable inside this function called marker. And what I'm going to say is while not marker equal to either an O or marker equal to an X, I'm going to ask for the user's input. So I'm going to say marker is equal to raw underscore input. And for this input function, it's going to be raw underscore input for Python 2, just input for Python 3. I can say whatever I want the actual line to be. So I can say player 1, do you want to be X or O? Question mark. And what I'm going to do is then call upper on it to automatically uppercase it so that it matches with uppercase O or uppercase X. And then I'm going to say if the marker is equal to uppercase X, I'm going to return a tuple in this case. Again, you have some flexibility on what you want to return. The way I've constructed this is so that it returns a tuple. So I can later on use something called tuple unpacking, which I'll show you much later on in this solution. But this is basically assigning player 1 and player 2, or the reverse, player 1 and player 2, based on that tuple position index. Let's go ahead and explore this function, make sure it makes sense to us. Alright, so I call player input, and I'm just going to run this. And then I see a little, you see it has an asterisk here, that means it's running, but that actually means because I have input, it's waiting for an input. So we get this little dialog, it says player 1, do you want to be X or O? So that's coming from this string here in raw input. And I'm going to say X, and then you notice it just returned X and O as their output. So that makes sense. Let's go ahead and run this again, type in O. Notice how whether I put a lowercase o or if I put an uppercase O, it still works because I called upper here. Let's go ahead and check, what if I put in the wrong type of value? If I put in a 2. You'll notice because it says while not the marker is equal to O or X, it's just going to keep asking for this raw input. So that's a great way to use a while loop to keep asking if you get the wrong type of inputs. And then once I actually put in a correct one, it returns the correct tuple assignment there. You'll see later on why we actually return tuples in our function. Alright, so that's it for player input. Let's go ahead and move on to step 3. But before we do, just let me break this down one more time. We're setting a variable called marker as an empty string. It's just, there's no space there. Then we're saying while not marker is equal to O or X, which is the reason we set it as an empty string. So we don't set it beforehand as O or X, otherwise this while not loop would never execute. We say raw input, player 1, do you want to be X or O? So if I just take this line, just to make sure you guys understand what raw input is doing, it's just going to, if I just say answer equal to raw input and run this cell, say player, do you want to be X or O? And I put in some value here and click enter. Then if I check what my answer is, it just sets it equal to a string version of whatever you put in. What's nice about this though, using raw input in Python 2, if I put in a 2 and click enter, it'll automatically still keep it as a string. So just keep that in mind. Again, if you're using Python 3, this should be input. Python 2, this should be raw underscore input. So that's all that's function's doing. And then upper, just to remind ourselves, if I have something like hello and call upper on it, it will just uppercase everything. Alright, that's it for our player input function. Step 3 was to write a function that takes in the board list object, a marker X or O, a desired position numbers 1 through 9, and assigns it to the board. Alright, this was actually really easy, even though it was difficult to describe what's actually going on, but all we should have done for this is say board at that position and set it equal to marker. You're just assigning that index position on the board list to that particular marker value. So that's all we had to do there. Alright, step 4 was to write a function that takes in a board and a mark, X or O, and then checks to see if that mark has 1. This one's a little bit more complicated. And it's a simple idea, but it just takes up a lot of typing. So what you have to think about is how can you write a function that takes in a board and a mark, X or O, and then checks to see if that mark has 1. Alright, go ahead and pause the video, see if you can figure this out on your own. Okay, so what we're going to do here is how can I win? Think of how I can win at tic-tac-toe. Either everything across the top matches, across the middle, across the bottom, diagonals, and then up and downs. So what I can do here is show you an example of what one of these would look like. I essentially want to do this. I take in that board list and a mark, and I want to check, let's say I just wanted to check across the top if they all matched up. Then I could say this, return board value at 7 equals that mark, and board value at 8 is equal to that mark, and board value at 9 is equal to that mark. And this would check if everything in the top row was the same. This would then check if the top left corner at 7 was equal to the mark, if the top middle was equal to the mark, and if the top right was equal to the mark. So that's checking across the top. So what we're going to do is keep doing these checks for every single possible win that you could do. And I'm just going to go ahead and copy this from the solution notebook because it's quite a few checks. There's a couple of ways that you can be more clever and get around this. I just went ahead and copied this here. But really, there's going to be a lot of typing here. And you can see here how we're checking it. And this one's also a diagonal check. All right, so we're using parentheses to make sure we mark everything. And then we're using the keywords or and to check everything. So each of these in parentheses is its own separate check. And then we're saying or to keep checking every other version of 3 matching in a line. And then we're just taking advantage of indexing here across our board to check for the wins. All right, and that's going to be down the left side. So that's step 4. What we're going to do is go ahead and stop the video here. Coming up next in the next video, we'll go through step 5, step 6, step 7, step 8, and we'll see if we can get to step 9 and step 10 in a reasonable time. Otherwise, we'll do a third video for that. But just to review what we've done so far, we went ahead, learned about from future print function, learned about raw input and input for Python 2 versus Python 3. We discovered how we could display the board, learned about clear output for Jupyter Notebook. We understood now how we can display a board and print it out in Python. Then we wrote a function that would ask the player for input and then assign a marker and then return tuples in our case. This you could do in various ways depending how your final logic game structure is going to be. Here we wrote a function that takes in the board, the marker, and a position, and then just uses list indexing to assign that marker at that position of the board. And then we wrote a function that takes in the board, a mark, X or O, and then checks to see if that mark has 1, which we can do like this by checking each possible combination across top, middle, bottom, etc. Okay, with that being said, thanks everyone. Hopefully these steps aren't too hard for you, but I do hope that this walkthrough guide does help you and that you find this video helpful. Again, in the next video, what we're going to do is going over the next couple of functions. Thanks, and I'll see you at the next lecture.